thank you guys so much for coming. We're just taking a few more seconds or so to sort of set everything up. But as we're warming up, like just so Jeffrey has an idea before he starts through the presentation, like who's working with time series data right now in their workload? Who's working with, is anybody working with the new MongoDB time series? Okay, cool, then you've got your work cut out for you. So let me go ahead and introduce Jeffrey here. He is I like to consider him a Texan, but he likes to consider himself from Chicago.
That's right.
But he did go to Rice, and so we still kind of claim him. Jeffrey Schmitz is an advisory solutions architect at MongoDB and has over 15 years experience working with time series IoT and Scala data. Scala data. And he's built real-time data pipelines at large enterprise companies such as Shell and Mercedes-Benz. He attended graduate school at Rice University in Houston, where he studied macroeconomics and is a certified Google Kubernetes engineer. And Jeffrey's home base is in Chicago, where he lives with his wife, 2 sons, and doggo Jake. Thanks, Jeffrey.
Thank you. Well, thank you all for being here today. Thanks for coming this morning. It's great to be back in Dallas. I finally got a good breakfast taco. It's been a while, so I'm excited about that. So let's talk about time series data. So what is time series data? I'm sure most of you out there probably know, but sometimes there's a couple people that don't know. So time series data is a collection of observations that are obtained through repeated measurements over time, right? Usually plots on a graph, and one of your axes would always be time. What kind of applications use time series data, right? Stock applications, connected car, SCADA drilling data, hearts beat per minute, right? Things where you're trying to build a living, breathing application, right? Where you're measuring not just what's happening now, but what may happen in the future. One of the recurring themes you're going to hear today throughout this whole talk is how at MongoDB, what we're trying to do is simplify your stack, right? We know you have all kinds of applications running all kinds of different databases, all kinds of different ETL tools, all just maybe a spaghetti factory of applications. What we're aiming to do here at MongoDB is slim down that stack. We see a lot of this. When I talk to customers, I see a lot of this, right? So we got 4 applications here, right? You got a caching layer. You might throw Redis in there. You've got your relational databases there. You're ETLing data all over the place. You got key value data. You got wide-com data. You got time series data, which we're going to talk more about, and graph data, right? All these different databases, document database, mobile database, right? All this stuff. Managing all this stuff is not probably the business that you're in, right? How many people out there are in the business of managing this stack or managing this kind of stack? Probably not many, right? So I know what you're thinking. Get to time series already. I'm going to get there. What we aim to do is simplify that stack, right? MongoDB Atlas covers you a long way here, right? WireTiger has a cache, right? People always try to throw Redis in front of MongoDB. Not necessary, okay? We have a cache. WireTiger has a cache, right? Atlas, you can store any kind of data, almost any kind of data in MongoDB Atlas. So we cover for graph data. We have an operator graph lookup that lets you query it. We have time series collections now. We can store columnar data. We can store key value data. So all the gray areas are where Atlas kind of takes away that spaghetti factory of text sprawl that you're dealing with, right? True enough. So let's get into time series. So in MongoDB 5.0, we released time series collections. And what time series collections is, it is a really, really good time series database that runs on MongoDB, right? It's not a separate thing. It runs inside of MongoDB. Your time series collections live alongside your operational data that's in MongoDB, your transactional data that's in MongoDB, right? So all that data is in one place. If you're serious about digital innovation and really doing predictive ML or predictive analytics, and all your data is like that slide we had before, all in different databases and being ETL all over the place, it's not going to happen. Talk to anybody that's a researcher in AI or a lead hacker in AI. You're gonna hear a lot about it today. You have to have your data in one place. You have to be able to ask questions of your data, of your time series data, of your transactional data, your operational data, all at one time, right? We also have a lifecycle, an automated lifecycle, where this data flows through what I like to consider like a living, breathing heartbeat of IoT real-time and near-time data. So basically what we do is we enable you to run MongoDB time series collections on MongoDB. It reduced storage costs. It's a super fast setup. So to build a time series collection, you're probably thinking, how do I build a time series collection, right? We're going to get to that in a second. Let's talk about some of the terminology. So before we had time series collections in MongoDB, we had a ton of customers already using us for time series. Why? Because the way MongoDB stores data on disk lends itself to time series data, right? Time series data, if it isn't coming in JSON, it's really close to being JSON already, right? So there's no conversion. With our flexible data model, you can store data any which way it comes in. So you're covered there. So we've had a lot of big companies using us for time series data, even before we had time series collections. But what we've done is, by introducing time series collections, we've upped the ante. So bucketing, where I was going with that, before we had time series collections, you had to manually bucket your data, right? You had to build that time series schema. What's bucketing? It's putting a bunch of entries into one document, right? Up to 16 megabytes. So you'd have time series readings all in one document, as opposed to storing it in the relational way, which would be, one insert per record, right? That's not good. It's not good for disk pressure. It's not good for performance. It's not good for anything. But now what we do is we automatically bucket the data for you. We automatically lay the data out on disk. We unwind it when the queries are done. So we've upped the ante in the time series game considerably. Creating a time series collection is also super easy. You can either do DB create collection and designate it as a time series collection. You have to have a timestamp. Without a timestamp, you won't be able to import the data into time series collections. You can do it this way. There's also a GUI. You can do it in Compass when you create database. You can just click. You can go to advanced options, click a little button that says create time series collection, or you can also do it in Atlas also when you create a collection. So creating a time series collection is super easy. Meta field. What is a meta field, right? So a meta field is a label or tag that uniquely identifies a time series. It never really changes over time, right? It can be defined as any data type. So we got bucketing, we've got metadata. What's granularity, right? How long do you keep the data for? So whenever you're in a time series collection, whenever you're in a time series discussion, how long do they keep the data? That's the most important thing, right? Is it coming in every second? Is it coming in every minute? Is it coming in hourly? And then how long do they want to keep it, right? How long before you do time to live index or expire after seconds delete on it, right? How long do you keep that data? You can manage that also with time series collections. Why is the milk on here? So actually, I had no idea why we had this milk on this slide, and because it expires. Milk expires. My boss had to point that out to me. I had no idea. But anyway, so that's why we have the milk here. And TTL is time to live index. So you can set your collections for how long you want them to live. Most people don't want to save time series forever unless they're building a historian, right? If you're building a historian, you're taking that data to the hot tier, you're working with it, and then you're moving it to a colder tier, federated storage, or somewhere managed in S3 where you're building a historian so you can go back over time and query that data. Bosch is one of the customers that I wanted to talk about just for a few seconds. They have been using us for their entire IoT suite ever since, for years and years and years, way before we had time series collections. They've got over 250,000 IoT projects, 10 million connected devices, and 33,000 supporting edge device. They've been using us for a long time. There's also a lot of big automotive companies that use us for time series. Bosch was using us before we even had time series collections for time series. And a lot of other customers were also. So how's this data indexed, right? A lot of you out there are probably thinking, okay, what do we do? How do we index it? So actually, we have a special index for time series data where the data is all stored by time in a similar space on the block so you can access it fast, right? This happens automatically with time series. So clustered indexing, it's pre-sorted by the index key. It allows the search key to map directly to the associated data rather than to the pointer. So this is where you get your performance from, right? querying time series data is super fast in MongoDB. If you guys want to get with me later today, I'll be here all day, and I can show you some demos on how fast it is to query it. Large, massive data sets in time series. This slide talks a little bit about how we point to a block of data, right? The index sizes are dramatically reduced, right? This is where the performance comes from. This is what it looks like inserting data from the Mongo shell into a time series collection. It's super easy to do. We're just doing a simple insert many on DB weather. And it's that easy, right? Querying a time series collection, this is doing the db weather.find, open and close parens, which is if you guys anybody's worked with a lot of SQL out there, it's like doing a select star all. This actually works really fast on large data sets, if you just want to bring everything back in at one time. Some of the internals, this shows kind of how, what the internals are. This is what you see on the left, and this is what's going on behind the scenes on the right. The metadata is going to be the sensor ID. Then you have your measurements, time, temp, dew point, rainfall, and ID control is going to be the internals. Columnar compression. So the time series data in MongoDB is stored in a columnar format. It dramatically reduces database storage footprint. It does have best-in-class compression algorithms. Again, you're going to see pretty crazy performance. We also have something called columnar indexes, columnar store indexes that's out, but that's kind of a different topic. So columnar compression is used by MongoDB. It's built on simple 8B. In its core, it adds a number of innovations that significantly improve the compression in situations where data does not consist of just neat columns, all made up of integers. So this is what a time series storage format looks like, and this is kind of where we get into what the bucketing is, right? So here is, if you're doing it relationally, you're just going to store one record at a time. If you put it in a bucket, it's going to look like this, right? And you're going to have all of your records in one document, right? So that's really, really, really good for disk pressure, better performance. You use less disk space that way, and in time series collections, we manage all that for you. You don't have to manually worry about your schema design or the way you're laying the data out on disk. So time series analytics, right? We've added some new temporal expressions. We have date add, which increments or decrements a date by a specific amount of time. We have date diff, which is like doing a diff on a file. It finds the date time difference between two date objects. We have date function, which trunicates part of the date object. You're going to hear a lot about aggregation stage, right? So aggregations are the way that you query multiple collections in MongoDB. MQL is what you use to query one collection, and aggregation framework is what you use to query multiple collections in MongoDB. You're going to be hearing a lot about that today in the different sessions. So for simple aggregation operators, we have running count, moving average, first, last. For advanced, we have derivative, integral, and exponential moving average are the more advanced functions. So one of the most popular queries with time series data is the Windows function, right? Where you're going to get, so this is the example, you get average temperature, and the temperature reading over the last 24 hours, eliminating any outliers. Pretty straightforward. Windows function is one of the most popular. Less than or greater than, also popular. If you want to query like all the well IDs, greater than this number, less than this number. Also very simple to do. So there are some new operators, top and bottom. It easily lets you compute the top and bottom element of the data and do set and returns on related fields without having to write a crazy query to do that. Min-max returns max and min elements with a first and last, return specified number, first, last documents. Densify is probably the coolest one and the most popular with our data scientists and our people that build visualizations. What Densify does is it does some gap filling and allows you, it fills in some missing data for you for your reporting and visualizations. One of the things we heard from people that build dashboards, that do a lot of graphical type reporting, is that when they have these gaps in their data and there's no data there, it screws up their visualizations, right? They'll be like blank spaces. So they'll have this really cool thing, and then they'll be like white spots. So what densification does is it takes a pretty good guess at, say you're ripping in like, 100,000 records a second, and you're missing like, you're missing some temperatures between, let's say you have 10, and then you'd have 20, it's going to fill in 15 for you in the middle. I think it shows it on the next slide. Yeah, so this would be the gap filling right there. Takes an educated guess, putting the temperature in between 10 and 15. And this is something that's, again, really important to data scientists, data engineers, right? Because they don't like to see those gaps. So the obvious question is, well, how true is the data if you're just filling in numbers? This doesn't happen everywhere, and usually in time series you're dealing with hundreds of millions of records. So trust me, you want that densification on. Data lifecycle management. So time series collections, we now support sharding, right? So sharding is how we scale at MongoDB. We scale horizontally, not vertically. We just add nodes to scale out, not up. Once you get over 3.5 terabytes to 4 terabytes, you want to start sharding. That is supported in time series collections. This is best for high cardinality use cases to increase storage capacity. Input is throughput, right? The more disks you add horizontally, the better throughput you get, the more performance you're going to get, right? Lower RTO. You're able to shard on your meta field or on your time field. This has been something that a lot of customers have asked for, right, is to add sharding to time series, which we now have. Automated data archival, and this kind of goes back, I like this slide, this kind of goes back to what I was talking about at the beginning, right, about that living, breathing application or data flow. So we have online archive now, we have Atlas Data Lake, we have federated query. So you can bring your time series data in to MongoDB Atlas. You can run all your analytics on it. I know for time series data, most people don't keep it super long, maybe 7 days, maybe 2 weeks. And then you can online archive it and move it to Atlas Data Lake, right, where you're paying a percentage of a penny a gig to store that data. And you might think, oh, well, okay, well, great, now it's out of sight, out of mind, but it's not. With federated query, you can still query that data, right? So running a federated query in MongoDB, you can query your data that's on Atlas, in online archive, in the data lake, or in the federated data space using Atlas SQL. So even though you've moved your data to a way cheaper tier of storage, you can still query that data, you can still work with it, which is very cool. If you're building that historian, or you want to keep your time series data forever on a cheaper tier to run analytics and try to gain insight on what might happen in the future from past experiences. So MongoDB charts. How many people are using Atlas now or have even used Atlas at all out there? So a lot of folks, right? So MongoDB charts now supports time series data. Charts is built right in. You folks who are working with Atlas have probably messed with it. It is built right into our Atlas stack. It lets you build really cool visualizations on MongoDB data. It sits right in Atlas. It sits right on top of your data. Again, go all the way back to that second slide I showed. There's no ETL. You don't have to move data back and forth. You can just build visualizations on MongoDB charts directly sitting on top of your data in Atlas. Charts is built explicitly to visualize JSON data. So it's very cool. Customers always tell us they don't want to use it. They have Tableau or Spotfire. And then they end up using it for all kinds of stuff because it's basically free. So here's the time series roadmap, some of the things that we have coming out. 5.0, so this did come out. This is not new. Time series has been out for a while. When we first brought it out, we had time series collections, of course. We had Windows functions, temporal expressions, secondary indexing. 5.1, we added sharding support, delete many on data that we added online archive, which is the last slide I just talked about having that whole flow, that living flow of data from bringing it into Atlas to eventually archiving it, right, to save tons of money on storage. In 5.2, we added columnar compression and densification. Densification is that gap filling, right, that I showed, right, where it's going to take a guess at any missing data so your visualizations are full and rich. Top to bottom accumulators, and then in 6, We've improved read performance, and we've added secondary indexing. We've also done some other things to allow you to do some more indexing on subfields and whatnot that was kind of missing. So a lot of cool stuff happening. That is it. Scott, you got a microphone out there if there's any questions. I am going to finish a few minutes early. I would appreciate if anybody could scan this, and if you absolutely hated my talk, let them know, and if you loved it, that'd be even better. So if there's any questions out there, I think Scott Stokes is out there with a microphone somewhere. It was. Or not.
I was hiding.
Did you go for coffee, Scott?
All right, sorry about that. I missed my cue. It was supposed to run all the way to the end. So we've got until, we got 8 minutes for questions. Or anybody out here?
Only questions I can answer.
You can definitely answer. You build the product. I understood that you had the densify clause, right? So did you mention that it will automatically predict the values that are missing and then it will project it? Like say, for example, if I had a gap between October 1st to October 15, I had a weather report on October 1st, I was missing data in between, and I had a data on October 15. So you're saying that between October 2nd to October 14, there will be a predictive analysis, and then the prediction will be shown as data?
Yes.
Hello?
Okay. On what basis does it predict? Like, what is your predictive analysis based off?
So it does a medium and minimum average of the data that's already coming in. So if you have a record set that's like 1, 3, 4, 5, it's going to fill in the 2. You don't have to have densification turned on. Some people are freaked out by it. They think, well, it's just making up data, right? You don't have to use it. But people normally choose to use it, especially if there's massive amounts of data, right? Because if you're just trying to do a trend analysis or figure something out, having 1 or 2 records out of 10 million.
So do you control that? Like, say, for example, can I set up, like, if I have a gap of more than, 100 records or 200 records, then I can use that densify clause?
Absolutely.
Do you customize it? Can
Yeah,
we customize
absolutely.
it? Okay. All right. But you cannot use this for real-time kind of data, right? Because from what I understand is usually the data scientists or the AML models use it because we want that kind of data to be accumulated, so it makes sense to have a predictive analysis. But what about the real-time data? So where can you use this densify other than in a predictive analysis?
Yeah, so densify would probably be more popular to use per minute data, right? Not real-time data.
Okay.
Yeah.
And you mentioned about the analytics running on the database and giving the graphs. So can that be integrated if I say, for example, I have a UI application, and I understand that through the Atlas itself, you can also create those charts and those graphs because it runs the analytics basically on the data that is in the MongoDB. Is there an integration of that with any other, something like a headless applications? What is that is advanced in that? Other than that, it can show up as a.
Yeah. So with the charts SDK, you can embed the charts that you build in Atlas in your applications very easily. As far as the second part of your question, I'm maybe not super clear on it. Were you asking if charts has integrations with other tooling?
Other tooling or applications or something like
Right. So the answer to that is no. But if you do want to use other applications for your visualizations for MongoDB Atlas, we have the BI connector and we have Atlas SQL, which lets you connect to Tableau. We have a name connector for Tableau. We have a name connector for Power BI. And I think we have one for Spotfire coming out. So you can use those tools to use other visualization tools. But yeah, charts is Atlas specific.
Understood. Thank you.
Yeah, sure.
All right, anybody else?
You gonna let me off that easy, huh?
One more.
So one thing you mentioned was how the data is actually stored on disk. So our use case, we've got different time granularities. So we'll have 15-minute data, and then we'll have data down to the second.
Right.
One of the use cases we have is aggregating that data that's down to the second up to the 15-minute level and then combining those data sets.
Right.
Does this have the ability to ensure that those two data sets would be stored somewhere on the same disk location to ensure joins and things like that were optimized?
Yeah, so yes. When you say Scott looks like you want to answer.
I've never used MongoDB. So.
Yeah. Okay, so cool. So when you say joins, and you know what, after, come talk to you after, because it's more of a complicated answer. But so joins in MongoDB is something called $lookup, right? It works great. We try to avoid doing a lot of $lookups because we're not a relational database, right? So it does work. You don't want to do too many of them, then all of a sudden you're back in relational land. So there is ways to lay that data out on disk and to data model that, the per second data and the 15-minute data, so you can query it together using aggregation pipeline. And I'll come down and talk to you more about it because that's more of a, yeah, sure. There's another question over there, Scott.
Can we have triggers on the time series?
I'm sorry, can you repeat that?
Can we have triggers?
Yes,
Okay.
absolutely, absolutely.
All right, we got time for one more before we hit the hard stop here at 9:30. There we go.
Yeah, there's going to be a lot of sessions about triggers and functions. I stress to check out my coworkers' talks about Realm App Services, GraphQL, Data API. Those are really powerful tools that work in conjunction with time series data. It'd be very cool to, you guys should check those sessions out.
My
All right.
question also something similar to the previous gentleman who asked. My use case is like close to near real time. We have thousands of events. Log comes in, and also I need to do a lookup like a last 10. So in that case, how the time series performance at that level of latency?
Oh, it's crazy fast. I can show you after. I can show you a demo after I come down.
Thank you.
Yeah.
All right, looks like we're approaching the 30-minute mark. So thank you guys for attending. Thank Mr. Schmitz for.
All right. Well, thank you so much. I appreciate it. Thanks for coming out today. Cheers.